Okay, so a couple weeks ago we were talking about Archimedes' principle and buoyancy and how things would float. And so questions that come up, somebody will say, how does a boat that weighs 100,000 pounds get out here and float? That doesn't make any sense. How does it stay on top of the water? And we talked about the fact that whenever it displaces water, that it's actually whatever the boat weighs total displaces that amount of weight worth of water. So the inside of the boat is actually hollow and it's got a lot of air. And so we talked about some of those kind of things. But one of the other big questions that come up is, how does an airplane fly? Again, here's something that can weigh hundreds of thousands of pounds. It can be extremely heavy if it's big enough. Of course, a lot of them we want to go lighter. But a plane can be extremely heavy and carry hundreds and hundreds of people and tons of cargo and all sorts of things. But how does it fly? And so we introduce another scientific principle that's called Bernoulli's principle. So we've talked about several things along the way, but Bernoulli's is kind of interesting because we've been talking about fluids and fluid pressures and Pascal's principle, how pressures get spread out evenly in a sealed container. But Bernoulli's is a little bit different. And so we want to learn a little bit about it. But first, let me just start by something that's kind of interesting. Like here's a little piece of paper. All this was a cutout of the front of a folder. I had a folder and I cut a piece of it out. So it's a little heavier than regular paper cardstock, and you can do this at home. So if you have like an index card or a piece of thin cardboard from an old Christmas box or something like that, you can do that. So it'd be really simple. If I set this card here and I go to blow it off the table, can I not just give it a good puff and blow it right off the table? That would seem simple enough. But I would argue that it's actually not going to behave in the way that you might think that it would. Well, I try. Let me see if I can blow a little harder. I don't know what's going on here. Let me use a little compressed air. Okay, it's doing the opposite of what you would think that it would do. You would think that if I had this on here, I could just give it a little puff of air and it should blow, because all it is a little piece of cardboard. Now I want you to notice that when I turn it around, if I were to do the same thing, oh, it's gonna blow right off the table, and now I gotta go down and get it. My cameraman, can you kick that over or grab it? Thanks. So when I turn it sideways and I blow on it, it'll blow right off. But when I turn it this way, it doesn't. And the reason for that is Bernoulli's principle. Bernoulli's principle is kind of interesting. What it says is that in terms of fluid pressure, that air that is in motion has a lower pressure than air that is sitting still. It actually is even more complicated than that. There's a ratio. The faster the air moves, or excuse me, not just air, but a fluid in general, but the faster the fluid moves, the lower the pressure gets, which is why when we talk about tornadoes, the pressure gets really, really low. And we'll say more about that as class goes on. But in this case, the faster the air moves, the lower the pressure gets. So we can use that scientific principle to make all sorts of things happen. For this little project right here, I want you to try to think about that. Why, when we put air and tried to blow this off the table, did the top smash down? Because that's what we saw happening. I tried to blow it off the table, but instead, as I blew the air under the card set down. So based on what little I've told you, the more pressure or the more air that's flowing, the higher the speed of the fluid, the lower the pressure. All right.